Hey guys, it's Shannon here from PNM. We're here today giving you another behind-the-scenes look at one of our solar panel facilities. The name of the solar facility that we're at today is called Prosperity. It's just south of the airport here in Albuquerque. Would you believe that in this entire facility, it's sitting on about 5 acres of land and it has over 2,100 solar panels? Thanks to Northern New Mexico College and the University of New Mexico, the project is helping students improve math, analytical, and engineering skills and prepare for the future. About 15 kids from Escuela del Sol Montessori joined us to learn about solar energy. Heck, it's right there in their name, the School of the Sun. These kids were eager to learn, and we were happy to show them around.
I'm Don. I'm going to be the tour guide today. What school do you guys go to?
Escuela del Sol.
And that means what?
School of the Sun.
School of the Sun. What grade are you guys in?
Fifth.
Fifth grade? So are you guys studying science and math? Is that what's driving this tour?
Nope, energy.
Energy. Okay. So this site here is called the Prosperity Solar Energy Facility. This site is a PNM facility. So it's been running for about 5 to 6 years. The solar panels that you see behind me produce about 500 kW of energy. 500 kW can support about 100 to 500 homes if the average home uses about 1,000 watts. If the average home uses about 1,000, would this be able to support a home? Remember, this is 270 kW. Instantaneously, if we're using 1,000 watts and this is producing 270, is this enough to support the load at your house?
No.
No, it's short, right? So where does that difference in power come from?
Generator.
From generators, other generating devices. If your house uses 500 kW and this is producing 500 kW, at that instant in time, this plant can feed that house. The problem is that this plant only produces that much power for that instant in time, for that solar peak hour of the day. So the rest of the day we have to supplement that power. So one idea was to have storage. We can capture that energy produced during the day at the peak hour at its maximum capacity and store it to be used at a different time of the day. Production doesn't match the demand. So if we can capture that production at its peak and shift it to be used at a later time when the demand is at its peak, then we've benefited from the renewable resource. That was kind of the idea for building this storage. This is on a clear day like today. This curve shows that we're ramping up to a peak production of about 500 kW that'll occur sometime after lunch. Okay, then what happens when it gets dark at night? Do you think this thing produces?
No.
No production at all. So this is night right here. And then this is a cloudy day. Look how the production goes up and down depending on the cloud cover. Okay. Does the load change like that at your house? Do you flip the switches off and on all day long on a cloudy day? We need to smooth that out somehow. And we're using the batteries to do that kind of smoothing on a cloudy day. Here, this curve here shows the production going up and down, and then we're using the batteries, the red line, to smooth that out and make it a smoother curve to be able to give you better voltage at your house. We have requirements that mandate that we provide a voltage that is pretty tight, within plus or minus 5% all the time. Otherwise your TV and your Xbox and PlayStations won't work the way they're supposed to. We're showing production on a cloudy day, and then we're using the output of the batteries and we're shifting it out in time to give a nice smooth curve or nice smooth waveform. That's called shifting. We're taking that energy produced during the day and sending it out on the power lines at a later time in a smooth fashion.
The PNM Prosperity Energy Storage Project is the nation's first solar storage facility fully integrated into a utility power grid and uses smart grid technology to advance renewable energy. Grid-connected solar PV panels and an energy storage system comprised of 2 kinds of batteries are linked to a sophisticated computer bank that collects up to 220 data points a second. The data that's being produced is incredible, and it will help shape the future of energy storage. This project is supported in part by a grant through the American Recovery and Reinvestment Act. All of the panels you see were manufactured in America. To protect power quality and prevent damage to customers' appliances and equipment, electricity flowing onto power lines must always equal customer demand for electricity. Grid operators have a short window of time to adjust for changes in demand or reductions in output from power plants. While we can control the power output from conventional power plants, the output from solar PV facility changes instantly, sometimes dramatically throughout the day as clouds pass by and as the sun makes its passage from east to west. To compensate, an algorithm is being used to tell the batteries when to discharge stored solar energy and when to charge or pull back. Variations of this algorithm are being demonstrated and the data analyzed to find the optimal strategy. Power planners work days, months, and even years ahead to lock in that needed power for customers. Workers at power plants have detailed operating and maintenance schedules to ensure they can deliver the promised amount of power at any time. In the industry, that power is considered firm, which means you can count on it, and dispatchable, meaning that we can generate and use it when we want it. Solar energy is neither firm nor dispatchable. Moreover, peak output from the solar panels occurs around 2 p.m. in the summer and is on the wane by late afternoon. Yet the most needed and expensive power utilities generates in the summer is between 4 p.m. and 8 p.m. Aligning output with peak means that customers will get more value for the investment in renewable energy. The use of more complex data sets, modeling, and analysis will allow us to use knowledge learned at this site on other parts of the PNM system and on systems across the nation. The project has been demonstrating the ability to use the battery to store the right amount of energy in the morning and subsequently deliver it the same day during the late afternoon peak. Gaps have been identified, such as the need for manufacturers to work more closely together and the need for better weather and cloud cover information. Visit pnm.com/solar storage to view this project at work in real time.